Hello, how are you guys doing today? My name is Lennon Kruznak. I am in CSSE, Computer Software Engineering, and we're going to talk about resistors as my first video. This is going to be a big amount of videos, so try to stay with me while I explain everything. So in my hands in the video, that's a resistor, believe it or not, the little blue thing. You take these little knobs and you put them, a black one on this side or this side, doesn't really matter, and then you're going to test it. So you only need to use from off, well, this 200 over here, all the way down to this. Well, I think that's a 2000 volt, and this is 200. So you're only going to use this omega side. So you just start at 200. This is a 10 because it works at that, and this is 10. So let's hit play. And throughout the video, I use different ones. This is my next one. Works at 100, so it's still below the 200 line. Here's my next one. Doesn't really work, so I go up to the next one. Doesn't work. Go to my next one. Works, so it's only 5 volts because you round up. Never really accurate. So glad to talk that with you guys. So thank you for watching about my resistors. Okay, so we're on blink 12 output, so let me just tell you, land and date, no big deal. This is the more important stuff down in this area. This is big importance. So setup runs and resets power on the board, void setup, so it's going to constantly do this over and over, reset the power, redo this code over and over. Do it to pin 12, not pin 13, not pin 9, pin 12. So there's a cord right here. This black cord is connected to pin 12 on the Arduino, and it says high, so it means on, low means off. So I'm gonna play this video. Hopefully it doesn't constantly take control of my screen like it was doing a little bit ago. On, off, just flashing, blinking. Notice the code blink. Does it for 1 second because it's 1,000, and it waits always a second. Waits a second to be on, so you really see it and doesn't just flash and you can't tell the difference. But nice to test out the code. Okay. So thank you for watching this part. Let's get to the next one. Let me start up my next code here. Same thing, still have the 12, but now we're adding a new output. So now we're adding output 11. So there's another cord plugged in. It's right here. It's this blue one. And it goes into pin 11. So you do the same thing here. Wait a second, then turn off because low. You don't really need to add the second. Not needed. It actually kind of like ruins some blinking together, as you see here. And we have a new thing, pin 11, which is actually the blue one, and it's just switching, waits a second, switches, wait a second, switch, sharing the energy. So it's really nice. So every time it pauses the video, but you get to see it. It's truly effective. But that's what we do. High voltage means low, same thing as the last one. So see you guys on the next one. Okay, we're back with our next one, fade. This is an example of how pin 9. Whoops, I need to change that to pin 11. Sorry, I didn't ever notice that. So yeah, we're going to be using all this nice math in here. So I'm going to watch the video real quickly so you guys understand what it looks like. You see it turn off, like kind of like fades out. It's really nice. When you get your own LEDs for your like walls, they do this. You can have it do this. It's really simple code, so we're going to go over it real quickly, but every time. So let's get started. Please listen. Okay. Doesn't ever want to pause. Alright, so we're gonna start talking. Oh my god, this is so annoying when it does this. It's done this to me on every video. Alright. LED number 11. It used to be 9, but we don't have it plugged in on 11. Oh, 9, so we're going to do that. PM is attached, so that's what that means. Brightness is 0. We're going to explain this a little bit more. How many points to fade by. So, like, it just gets dimmer by 5. So say brightness of 0, can't really turn off much. Alright, so we're gonna send output. It's not really sending us output, well, energy, because all the energy is coming from the computer from the Arduino, so you can't really input any data, well, any of that. So it's always output for right now for these little small things. And now we're going to talk about this little loop. So you set the brightness of 11. Well, yeah. Set brightness, pin 11, analog, LED, comma brightness. That means set pin 11's brightness to whatever brightness equals. So pin 11 goes to 0. You don't have, so that's kind of like where it fades to 0. So, and then come down here, change brightness equals brightness plus fade amount. Fade amount is, well, fade. So it's going to do whatever fade does. So how many points you would fade by. So this right here is 5. So it does all this math. It doesn't like that. It does this math so quick, it's insane. So it's going to add. So like normal math. So 0 plus 5, that's basically this math is, but it equals whatever brightness. So first round, 0 plus 5 equals 0. Brightness is not greater than 0. It's false. These are your true and false statements here. So it's false and then false, but it'll keep doing this entire code over and over and over and over till this equals that amount. And then fade amount. It's really complicated math. And then you're going to do minus it once if it, say, is greater than, brightness is greater than or equal to 255. And then it'll do fade amount equals minus fade amount. So that's when it'll do fade amount, whatever, say 255 minus 5 equals 5. And it'll wait 30 seconds, seeing the dimming effect delayed by 30 seconds. Well, not 30 seconds. It's like quicker. So quick. So that's what that code is. And then see the video again. Beautiful fade. It's actually really cool seeing that. So we're going to get into the next part. Hello, we're going to talk about our last part, analog serial. I'll talk about the code in a sec. So you see this moving in the video. I do all this amazing work that I'm going to show you guys. I'm just turning a knob, and it's doing all this amazing settings change. And it goes up, goes down, all because of this code. So let's talk about it. Alright. So analog reads, set up the ruins reset. So serial bits 900 per second. So it's taken in every spin and then sends it. So no big deal. Loop runs over and over and over and again. So read input pin 0. This is plugged into pin 0. Actually, yeah, analog 0. So it's not, yeah, that's what this means, analog 0. So that's where we plugged it into. So it's taking all this data from like a middle piece in that video. That little, it has like little spikes, like a rake down the bottom. Let me actually pull up that video again. Every time it plays or loops, it'll take control of my screen. So actually this is a little bit easier now. Getting sick of it. So pause. Right here, down in this little area down the middle, is what this analog is plugged into, analog 0. This is, doesn't matter what these two are plugged into, but that middle one is crucial to this entire system. But yeah, you read serial number decay by 1, decay. So every time you turn it, that's what it's doing. It's decaying by 1. So say you fast turn it, you're probably decaying at 1, but you're moving it so fast, it's reading so much more information than what you're actually sending it. So that's why. So that's a fun fact. So that's all we did. Thank you.